All right, guys, this is section 4.4, rational functions. We are starting this. We might get through the notes today. We'll see. Okay, here's the deal. Listen. We have 3 examples of rational functions, and they get like progressively harder, or more disgusting looking for each of the 3 examples. So the first one, wow, I have a really big marker here. Here we go. The first one is 1 over x. This is what the root of a rational function looks like, okay? Now let's talk about his graph for just a second before we move on. Yeah, he's a boomerangy thing, okay? Now, when you start putting stuff in there, he moves around and shifts a little bit, okay? So before we talk about another graph, let's talk about the vertical asymptotes and horizontal asymptotes. This guy has a vertical one here at x equals 0, right? That's x equals 0. Then this guy is a horizontal asymptote. I call him a ha at y equals 0. So there's your ha, and then the other one is called a va. Those are vertical asymptotes, horizontal asymptotes. That's what those guys look like. Okay, now, you might have something funky weird happen every once in a while where you have 2 vas. Okay, let me show you what that looks like right now before we move on. Sometimes you will have 2 vas. Let's say they are there, and let's say we have a ha still here, right? So we have a horizontal one. You will only ever have 1 horizontal asymptote. Never more than that. Sometimes you don't have any horizontal asymptotes. We'll get to that. But you will only ever have at most 1 ha, okay? You can have more than 1 va. Usually you'll not have more than 2. It's possible, but usually not, okay? Oh. And what does this thing look like when you have 2 vas? It's smooth. Here is what he looks like, okay? He's kind of weird. He still has boomerangy things, and one's down here, but the other one is
right there.
Right here.
Yep.
Okay, and this one is kind of like a parabola thing in the middle. Okay, so when he has 2 vas, most of the time he's going to look something like that, or he might be in the other quadrants instead and look like this, right? Look like that instead, okay? Makes sense? So 2 vas, he might look something different than just the boomerangy things, okay? So just prefacing with that, that's a thing that could happen. No. No. Get your notes out. Go.
It's out right here.
Yeah, okay. But put everything else away so you can record some notes here.
No.
Okay, I've given you lots of good information here, and you haven't written anything down. All right, now we start to put numbers in here, like this function, and he starts to move them around, and he makes the vas and has in a different spot, etc., right? And then this one's really super ugly. Okay? So we're just adding more numbers, changing things about him. There he is. Okay? Those are all rational functions. So, what are some things that a rational function has to have? An x in the bottom. Yeah. He has to have a variable in the bottom. Emma Carr, shush. He has to have an x in the bottom. Yeah?
Yeah.
Okay. Now, let's talk about domains. There are 2 things. If you guys aren't going to listen, I can teach you after school. That's an option, right?
No.
Okay, domain of a rational function. We've talked about domain before. We've talked about 2 things that screw up the domain, and they are a negative inside of a square root and dividing by 0. Those are the 2 things, okay? Now, when we are dealing with rational functions, we are only ever dealing with one of these, and that is which one?
Divide by 0.
Divide by 0. This is the easier one of the 2, so that's kind of nice, right? So we're talking about we're not wanting to divide by 0. Not wanting to divide by 0, okay? So we're looking at this guy here, and what would x have to be in order for me to divide by 0? 1 over x squared. What? 0. Like x can't be 0 in this case. If I try to plug 0 in here, 0 squared is going to be 0. I can't divide by 0, right? So we would say for the domain is that x can't be 0, yeah?
Yep.
Okay? All right. Now, I'm going to do one more thing, and I'm going to talk about a vertical asymptote in relationship to the domain. asymptote. A vertical asymptote. A vertical asymptote. So we said that according to the domain, you guys are not listening. We said according to the domain, the x cannot be 0. Yeah? Okay? And the reason why x cannot be 0 is because
That's the asymptote.
that's where the asymptote is. There's a vertical asymptote here at 0, and then I have my boomerangy function. Now, There is one other little change to the graph. What happens if he's 1 over x squared instead of 1 over x?
It's a parabola.
No.
Okay.
He's still the boomerangy, guys, okay? But when you take and square something, it can never be negative, correct? Right?
Yeah.
If you take something, even a negative, and you square it, it's always going to be a positive.
Oh my gosh.
So we
there's
have
only
this
one
guy.
boomerang.
No.
The horizontal is just moved up.
The other one goes this way. It looks like a
Oh my
volcano
gosh.
instead, right? Instead of having him down here, he's flipped up to the top. So this is the graph of 1 over x squared. You will see that again.
So there's no horizontal.
Put that in your brain. 1 over x squared looks like a volcano. 1 over x is in the first and third quadrant. 1 over x squared is in the first and second quadrant. It looks like a volcano. Commit that to your memory right now. That's important.
Quadrant number 2 is negative. They go negative.
No, the y coordinates are negative. So the
Yeah.
x's can be negative, but okay, so that's a good point. The x's can be negative, right? But when I insert a negative in for x and I square it, the y coordinate becomes positive. Yes, good,
Oh my
good thought.
gosh.
Okay, part B. We're looking at stuff on the bottom here, and we want the bottom not to be 0. But that's a really big bottom. X squared minus x minus 6. That's a lot of stuff. Let's break it down. Right? We can break that bottom part down. What can you multiply to get 6, but when you add them give you -1?
What?
We want to break this down as a simple trinomial. Multiply to get 6, add to get -1.
3 and 2.
Woo.
3, 4 and 5. 5 and 6.
X minus 3, x plus 2. Yeah? Okay. Now, if that's what the bottom breaks down to, that's what my new bottom is. That's what the bottom breaks down to. What can x not be?
3 and -2.
Or -2.
X cannot be positive 3. X cannot be -2. Do you know why?
Because
Because that's what
then it
x
would be
equals.
0.
What happens at 3?
It goes to 0.
A vertical asymptote.
This is where your vase are.
Yep. That's what it said.
Don't worry.
That's where the vertical ones are. Okay, so at -2 we have 1, and at positive 3 we have 1. Okay, that's what those look like.
Yep.
That works.
Yes?
Yep.
Happy with that?
Happy.
Okay, so where your domain errors happen, your vertical asymptotes happen. So, domain errors, ERRORS, equal vertical asymptotes. Okay, so if your domain error, for example, is x is not equal to 2, what is your vertical asymptote?
2.
X equals 2 is your vertical asymptote, right? The equation x equals 2. What happens if your vertical asymptote is x can't be -5?
Then your bar is negative.
X equals -5. Those go together, right? X can't be that, therefore x equals that is your vertical asymptote. Okay? Makes sense? That's where your vase are located. Happy with that? Okay. All right. Let's go down here and let's talk about x and y intercepts. Okay? Let's do over here the x-intercept, and let's talk about y-intercept. X-intercept, y-intercept. Okay? Which one's easier to find?
X. Y.
The y is easier to find. How do you find intercepts?
Plug 0 in for the opposite.
0 in for y,
Great.
0 in for x. 0 in for y, 0 in for x. Let's do the y-intercept first because he's easier. F of x is just the fancy way of saying y, so we've got y there. And then we're just going to plug 0 in for all of the x's. You can do this in your head probably.
2.
Y equals 0 squared minus 0 minus 2 all over 0 minus 1. Okay, what's left on the top?
-2.
-2 over
-1.
-1. So the y-intercept is at 2. It's touching at 2. Now I give you the graph over here. Is he touching at 2?
Yeah.
Right there. Right there. That yellow dot. He's touching it 2. Okay, now the y-intercept, or excuse me, the x-intercept, we plug 0 in for y. Okay, y is this guy right here. So we plug 0 in and we get something like x squared minus x minus 2 all over x minus 1. Okay, now how do I solve for x when I have 0 over on the other side?
Flip them.
Kinda. No, we can't flip them.
Multiply by x minus -1.
Okay.
It just goes away.
Yeah, multiply by x minus 1. Okay, now, every single time you do this and you set it equal to 0 and you multiply the bottom over, the bottom will cancel out because anything times 0 is just 0. So when you are finding the x-intercepts, you are only looking at setting the top equal to 0 basically because the bottom just cancels out. Make sense? Always. Okay? Now this guy's a simple trinomial. Kelsey said, what can you multiply to get 2, but when you add them give you negative 1.
1 and negative 1.
No.
2 and 1.
2 and negative 1.
You
Negative 2
dumb
and 1.
bubble.
Negative 2, positive 1. Like the 7th time's the charm, right, Kelsey?
Hey, I said 2
Okay.
and 1. I just did 2
So the x-intercepts are x equals
1.
2 and x equals.
Negative 1.
So is he crossing the x-axis at 2 and negative 1? Right there. I'm right there. Do you see him? Yep. There he is. Okay. Good, good. Okay. Let's go down to, I'm going to skip the big little concept. That's that. Without a calculator, describe the graph of this thing near x equals 2, then sketch the graph for the values near x equals 2. So here we go. X equals 2. If I plug 2 in, let's just talk about plugging 2 in. 2 here, 2 here. Okay? 2 plus 1 gives you 3 on the top, but on the bottom it gives you 4 minus 4 is 0. So what happens there?
It's not.
Not going to be a thing. That means I can't plug 2 in, which means what's happening at 2?
It's a vertical asymptote.
X can't be 2. Va lives there.
I'm not kidding.
Okay, Ava lives there. So, let's talk about what's happening at 2. We have a vertical asymptote at 2, blah, 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 blah. Like that?
Whoa, that was a lot
Okay.
of laws.
Okay, and one more thing let's do. Let's do something, I'm going to make a table of values.
Something crazy.
Let's do this.
Yeah.
X and then Y. Okay, I'm going to put 2 here in the middle. 2 is undefined. Okay, we cannot plug 2 in. Okay, but let's plug in like 1. And let's plug in like 3, but also let's plug in 1.5, let's plug in 2.5, and let's plug in like 1.1. We're plugging numbers that are really close on, no, wrong, 1.9 and 2.1. There we go, that's what we want, okay? Numbers that are really, really, really close to 2, we're going to plug in and see what happens on either side, okay? So help me out here. Once you have it plugged in, you can just change the numbers, but plug 1 in. I plug 1 in and I get 2 over negative 2. So I get negative 1 when I plug 1 in. Great.
Yeah.
Do 1.5, 1.9, 2.1, 2.5, and 3. I'll do 3. You guys do the other 4. Go.
That's not what I said.
4 over 2 is, no. No. 4 over 2, which is 2. Okay, there we go. Plug in 1.5, 1.9, 2.1, 2.5. Go. Plug them in.
I can't see that.
Somebody start from the back. What?
Start from the
It's
back.
literally on your notes, child.
Arch my back. Once I arch my back, let me attack these numbers. Don't need a. Because I'm the moderator.
Calculator.
Yep, I'm the
2.5 over negative 1.
If you already
Negative
said I'm gonna
2.5
get
is
it from the back.
1.5.
What? No, we want positive 2.5.
Arch my back.
We want positive 2.5. What is it?
So this is what we put on top.
1.5 is
I have these
negative
both
2.5.
candles because my sister turned 19.
1.5 is negative 2.5? Okay. 1.9.
Girl,
Go.
Mommy.
Anybody else have any of these? Get your calculator out and calculate. Go.
Oh, I can put that emoji. We can arrange that.
If you're not going to participate, well, you'll participate later.
No, I'm participating.
What?
2.9. It's 2.9 over 0.02 or something like that.
I don't know.
I don't know what it is.
I'll do 1.
Anybody else have any others?
1.9 is approximately
Negative.
2.9 over negative 0.2.
Which as a decimal is what? A big, big number.
I got one. It's negative 5 and 2.5.
Knock knock.
That makes sense.
2.5 is what?
14.5.
I got negative 14.5 for 1.9. For 2.1.
That's also what I
Yes,
got.
great. For what? Rachel, what? 2.5, you got what? You're right. I heard you say it. 15.5 right here? For 2.5?
No.
Yikes.
2.1.
2.1, you got 15.5? Okay.
Oh, I got negative 0.85.
Anybody got 2.5?
I'm getting there. 3.5.
Okay. Okay, this does exactly what I thought it was going to do.
Does it really?
Yes, it does. Okay. All right, let's plot these points. If you need to complete the table, there it is. This guy is undefined, so I'm going to put a U there. Undefined.
Why is my number so random?
It's just the way it is. Whatever.
Just the
Okay.
way it is.
All right, 1 is at -1. So I'm going to go over here to 1, and I'm going to go to -1. There he is. 1.5 is -2.5. And then 1.9 is like all the way here at 14. Do you see what's happening?
No.
It's doing like one of these.
Ooh.
Yeah, do you see that? It's approaching in like a really big negative numbers down below. That means it's going toward infinity the closer we get to 2, okay? Now on this side, let's start from 3, 2, and let's work our way back this way. 3 is at 2 right here, okay? At 2.5, which is in the middle, is up at 3.5, and then at 2.1, it's at 15. Do you see what's happening there?
He's a boomerang.
He's doing like one of those, right? Okay? So those numbers should get larger the closer you get to that vertical asymptote of 2, right? On one side, they're going up to be really big numbers, like 15.5 is going big. 14.5 is going small. He's going down.
Teeny weeny.
Okay? Big and small. He's going up on one side, down on the other side, right? If we were to plug in like 1.99, right? It would probably be like, I don't know, -100 point something, right? Does that make sense? Okay? If we plug in 2.01 instead, he would probably be positive 100 point something, right? Okay? Like really, really big numbers. Okay? Makes sense? Okay, so that's what a vertical asymptote is doing. It's going up and down really, really extreme on either side of that vertical asymptote. Okay? All right, so let's go down here. Finally, they're introducing vertical asymptotes to us, okay? Now, finally, we have the concept of vertical asymptote. I've been talking about it the whole time. How do you find a vertical asymptote? Where?
The domainers.
Domain error happens. Okay, so in other words, like, how do we find those domain errors?
Set X.
You're looking at the denominator. It's the denominator equal to 0. Circle that, star that. That's how you find the VA. Vertical asymptote is the denominator equal to 0. That's the VA. Okay. Okay, you need to sit up. You need to sit up. Both of you, sit up and listen.
None of them were taking notes.
What was that? I was working on physics and then.
Gracie opens her eyes.
I think we'll just start taking quizzes from now on every day like we used to. That would be great. Let's just do that. Plan on that tomorrow.
That sounds like a way to go, guys. Thanks for not paying attention.
Let's just do that.
I had physics.
You are sleeping. You can't look at my
Yeah.
paper because it's completely filled out.
Let's do that. Yep. We'll plan on that until we can get everybody paying attention. Okay? Yeah, sounds good. Denominator equal to 0. That's your VA. That's how you find it, okay? Now, sometimes it will look like this, where he's like a volcano upside down. He's approaching like that on the other side. We're really going to have quizzes tomorrow. Great. Great. Sometimes he's going opposite directions. So one's going up, one's going down, yeah?
Yep.
Or sometimes there's a volcano with both going up, yeah? Like that and that, okay? So he can have either one of those things happen relative to the vertical asymptote, okay? Volcano going down, volcano going up, or opposite directions. What?
The last one doesn't have a huh.
Yeah. Yeah. We'll get to that. It's fine. It's fine. It's fine. It's fine. It's okay. Yep, it'll be all right. Okay? All right. Next concept. So we talked about vertical asymptotes. That is concept number 1. Concept number 2 is holes. And then the third thing is called a horizontal asymptote, which where is that at?
Ha ha ha. Get it? It's ha ha.
There's another page?
Yeah.
I don't have the other page. I don't have the other page.
It doesn't have ha's. There is no
Get it?
ha.
Vertical asymptotes are funny because they're ha's.
Okay.
Yeah, you know that was funny, Sarah. I knew it.
Okay, so here's the deal. Let's take a look at this function right here. It's off to the side of that whole box, right? Like this is what holes are, okay? All right, check this out. These get disguised as vertical asymptotes all the time, but they are not. So here's the deal. X squared minus 4 over x minus 2. It looks as though we have a VA at x equals 2, right? It looks as though we have a va at x equals 2 because of this, right? X equals 2, except
You have a hole there.
he is technically a hole in disguise, okay? If we look at the top, x squared minus 4, that is a difference of squares, right? And we factor it down and we call it x plus 2, x minus 2. Do you see how we broke it down? Okay? Now, the x minus 2's cancel out, which means that instead of having a va, it is not a va. It is actually a hole at x equals 2.
Even I knew that.
Okay? It's a hole at x equals 2. So, when is it considered to be a hole? What happens when it's a hole instead of a va? How do you distinguish between?
If the bottom cancels with the top.
If the bottom cancels with the top. So if it occurs in the top also when it cancels out, that's actually a hole and not a va, right?
Wow.
So always check that. Even when you see.
Wait, say that again?
So like when we broke down the top, it canceled with the top and the bottom. Like these two, it showed up in the top and the bottom. That means it's a hole and it's not a va. Okay? So if it was just like, let's say x plus 2 over x minus 2, that would be a va because it doesn't cancel with the top. Right? Okay? All right. Let me get rid of that. Okay, now, what's left over? This is kind of fancy. What's left over if we cancel it out? If it's gone, it's just x equals 2. What type of function is that?
It's a line.
It's just a line. This is a linear function. Y equals x plus 2. It's not even a rational function anymore, right? So y equals x plus 2. They went ahead and graphed it. Hold on. They went ahead and graphed y equals x plus 2. You start at 2 and you go up 1 over 1, up 1 over 1, and it makes this line right here, except, you see what they did right here? There's a hole at 2. So wherever my graph would have touched an x coordinate of 2, that's where my hole occurs,
Wait,
right?
so if it has a hole, it's a line?
Not necessarily. Like if it was instead, like let's say I had like an x to the third power function over like x plus 2 and I canceled this x plus 2, it would have x squared left over, right? And it would still be a parabola with a hole, right?
Yeah.
Does that make sense?
But it
Okay.
won't be a rational function if it has a hole.
Right. Correct.
Holes
Yep.
equal irrational.
What are you talking about?
They're not rational.
Okay, whatever. Or holes are just polynomial, like it's just a polynomial function. Okay, sure.
Yep.
Okay, makes sense? Good? Yes?
Yep.
Okay, happy with that. That's how a hole occurs. So, if it looks like a va, check to make sure it doesn't cancel with the top because then it's an actually a hole instead. Good? Perfect. Okay, let's go down here and let's talk about these and then we'll stop. We'll stop before we get to slant asymptotes. Okay? All right, list the vertical asymptotes and describe the end behavior of the graph of the following functions. Okay, whatever. Let's do vas, and then some of these might be holes. Except they're not. They're not. All of these are vas. Okay. So, we want to find the vas, and the vas occur where the domain errors occur, which is like where the bottom is. Can you do that math in your head?
Yes.
Like to figure out what x can't be?
Yes.
So how do I do it?
Set it equal to 0.
Just set it equal to 0. 5 minus 2x equals 0, and then do the math, right? Okay. I'm going to add the 2x over rather than subtracting the 5. So 5 equals 2x. Divide by 2, x is 5 over 2 or 2.5. So I have a va at 2.5. Make sense? So if you can't do the math in your head, just go ahead and set it equal to 0, right? It's the denominator set equal to 0. That's where the va is. So if I'm asking for domain, what's the domain of this function? X can't be 2.5, exactly. We can't have a value at 2.5 because that's where a va occurs. Okay? Now, does it actually cancel out of the top also? Does like anything factor out of the top and the bottom? Right? So he is a va and he's not a hole instead. Okay? Good?
Good.
All right, B. Va. What? Oh, we have to sketch graph. We'll talk about that here in a second. Okay? We'll maybe sketch graph. We'll see. We'll see. Okay? We'll maybe sketch graph. X squared minus 4 is my bottom. Okay? Be
X
careful.
cannot be 2.
Okay, so to do the va, we set the denominator equal to 0. X squared minus 4 equals 0. And
Square root of
that 2.
4.
add the 4. X squared equals 4. And we take the square root. But
Domain equals x can't be 2.
Plus minus.
right? We have two vas here. One at positive 2, one at negative 2. So that means my domain is that x can't be 2 or negative 2, right? Okay, so if we want to sketch a graph of this guy, I'm just going to sketch where the vertical asymptotes are. So we have a va at 2, and we have a va at negative 2. Okay.
He's got a parabola in the middle.
So he's got a parabola in the middle. Okay. And we don't know where the horizontal asymptote is, but we'll talk about that tomorrow. Okay. I'll talk about horizontal and slant asymptotes tomorrow. Good. Okay. That's where my vase are. Okay. All right. This guy. We set the bottom equal to 0. So x cubed plus 1 equals 0. Then what?
It'd be -1.
X cubed equals -1. We move the 1 over to the other side. And then we take the cubic root of -1. Wait, is that imaginary?
No, because it's cubic. Cubic equals you can have.
Yeah.
negative.
So x equals, is it plus minus?
Yes.
No,
Why?
Not with cubic roots. Right?
because it's
Right.
just -1.
Because what do you take times itself 3 times to get -1? It's only -1, right? Positive 1 times itself 3 times won't give you a negative. So it's only -1. So I only have one va, right? That's my va.
Domain.
And then domain, x can't be
-1.
-1. Okay, one more example real quick. Sorry. I'm going to say just x over x squared plus 4. If I'm trying to find the va.
Is it a whole?
Uh-oh.
Are you
No.
Josh?
X squared plus 4 equals 0.
Imaginary.
X
Yeah,
squared equals
Because
-4. Square root, square root. So x
Yeah.
equals
Or I.
plus minus 2i, which means
Oh,
what?
shoot. It's imaginary.
I have imaginary vase, which means what?
There is no. It's not.
No
existent.
vase. Okay, what about domain?
Well, your domain is.
All reals.
Yeah.
Domain, I can plug in anything I want to, right? We're adding 4, we're not subtracting 4. So any number I plug in there will never end up giving me 0 on the bottom, right? So
what's
the
that gonna
domain-
Look like?
Domain is going to be all reals.
What's
What?
it look like then? Just a connected volcano?
So a lot of times what it will do is it will look like, I don't know, this is weird, but you might have seen this before. It kind of looks like an M, so it'll go up and then it'll come back down and level off, and it'll go up and come back down and it'll level off. Sometimes it looks like that. Okay. It kind of looks like a mustache, yeah. So it doesn't have a vertical asymptote because he actually touches at 0. Like he doesn't have a, whatever. But so that's sometimes, I'm not sure if that's what this guy looks like, but it's probably some variation of that, right? Okay. No va though, but he does have a horizontal asymptote. If he's leveling off at 0, that's kind of what he looks like. Okay. You can graph it. Sure. Graph it to see. See what it looks like. See if it looks like a
Oh my
mustache.
God. Tell Maya to stop choking me out back here.
X over x squared plus 1. Alpha y equals enter. I might be way off. It might not be a mustache.
So fast.
I'm going to give you the homework so you guys can look at it.
Joking. She did it first.
You did it first. Why did you do that?
Kelsey,
You did it to
what?
me.
I was just holding Tiger's face in that picture. I wasn't choking him out.
Pink and blue candles.
He was being crazy. He was trying to bite me in that.
This says April.
It looks like this.
This?
It's like a flat line on bottom.
Is it April, not August?
Okay.
It's 5 months. Why did you say?
Because it looked like you was poor.
What are you doing?
mustache, but
He's being a whore.
No,
it's
definitely starting
Those are disgusting.
9 months.
They are disgusting.
They're not that good.
So good. I
They're
could eat these
so
all
gross.
day.
No, those are gross.
What'd you take home with your this man?
So this one, Sarah just graphed it, and it does look like a mustache, except I'm going to get rid of this guy over here. He is actually, here's my line. He's actually a mustache this way. So he's like one's on the top and one's on the bottom. It's like the first and third quadrant. So it's kind of a mustache, but like the one's going down. So like,
Okay,
whatever.
now
Okay?
can I use your assistance when we're done?
Okay, happy with that?
Yeah.
I'm going to give you the homework assignment so you can do the first couple of them at least and get a start on them. There's only like 10 problems total today and tomorrow, so that's kind of exciting. And they're really not that bad. I don't feel like vase take forever. So anyway, bye people watching this video.